Hello everyone. Now wait is over for the next discussion session of the AIATS Plus program for the phase 2, and we are discussing here the mock test number 8. The examination was conducted on 9th of March, and yes, I am Nidhi Panwar, your chemistry faculty, and I'll be taking some of the important segment from the chemistry. So the chapters, those I'm going to take here, आपने अपना लिंक के साथ भी पढ़ा होगा डिस्क्रिप्शन में. So the main chapters, those I'm going to take here, the some basic concepts of chemistry, structure of atom, the periodic classification, chemical bonding, and simultaneously one chapter from class 12, that's chemical kinetics, right? So the content I told you, and the turn comes for the discussion of this important paper. The program is very important because this is for the personalized learning for ultimate success, and success which is there in the NEET examination, and the best wishes from the teacher's side is always with you, but the important thing is keep practicing more and more questions so that you can get the confidence. And for the same, we have this paper with us, and simultaneously I'll be taking questions, we'll be discussing the concepts behind and try to solve, I mean with respect to that paper, some of the questions I've already taken additionally, right? So let me just begin this discussion session that I'm taking here, and I'm starting with the question number 50, right? So all those who have not yet joined, and if you want, you can share the link. Good afternoon everyone, those who have joined, and people, if simultaneously they join, I'll be telling you that what we are discussing, okay? So shall I begin this? Okay, let's start. So the first question is there from the chapter Chemical Kinetics, and the this question says the rate constant for a chemical reaction taking place at 500 Kelvin is expressed as, K value is given. What K is? I hope you know that K is rate constant, right? Here this A is Arrhenius constant, and exponential form has this minus 1000 here, right? Namaste. Namaste, Bushra, Eldorado, and Lakshmi. Those who have joined, I'm able to read the names, but if I'm not able to read the name, don't worry, I'm just looking at you all. Try to solve the question, write the answer, and simultaneously you can match. If you have attempted the paper, you'll get that how many, how you solve the question, whether answer is correct or not, and how the concepts being applied in this question, right? So these are the few of the things, those we will be taking care during this session. Now, so equation you have, and you have to find out the activation energy of the reaction if the rate constant is given and the temperature is also mentioned here as the 500 Kelvin, right? Okay. So this is the question from the chemical kinetics, and it is based on Arrhenius equation, as I have already written here that A is the Arrhenius constant, right? Now what is the effect of the temperature on the rate of reaction? If someone asks you that if you are raising the temperature by 10 degree, then what happened to the rate of reaction? So general statement you can say that if you are raising the temperature by 10 degree, generally the rate of reaction gets doubled. It's been observed experimentally, right? So there is not a single formula that we are going to take, but yes, it's been observed experimentally. Now Arrhenius worked on the same, and he derived one equation. What that equation is? The rate constant is directly proportional to, so I'm just taking directly here the constant A, e raised to the power minus EA upon RT, right? This is the Arrhenius equation. And if you just look at the expression given here from the question, that K is equal to A E minus 1000. So this was the equation 1 that I'm considering, the Arrhenius equation, and the given equation 1 and 2. If you just compare these two, isn't it that easy to find out activation energy? Because what we need to do? Namaste Bimal. So Bimal, what we are doing, we are discussing the questions from the AIATS Plus program, test number 8 it is, and the first question that I have taken in my turn, the first question is question number 50 here, and where you have to just find out the activation energy for a particular reaction for which K value is given, right? So the K value is given and I have just compared the two equations. One is the given one and the second which we know from the Arrhenius equation, right? So that I have just written here. If you compare these two, what I observe, see, if I divide first equation by second, then can I just simply say that minus EA by RT is equal to minus 1000? Okay, let's erase this minus as well because it will cut this way. So, what would be the value of EA now? EA is equals to 1000 into RT, right or not? 1000 into RT. Okay, now the next thing. If I'm just looking at the options given here, what I found that EA is given in the unit calorie per mole, kilocalorie per mole, here in the three options, right? So, in terms of kilocalorie per mole, let's try to find out, then we'll match the options, okay? So, now the R value in calorie, I hope you know what's the R value in the calorie? Yes, 2 calorie per Kelvin mole, right? So, rather in the calorie I have taken the value of R, and if answer is in kilojoule as well, kilocalorie as well, not kilojoule, it's kilocalorie. So, what I'm going to do? Hello electricity. I'll divide it by 1000 to convert this 2 into kilocalorie per Kelvin mole, right? Yes. Into the temperature is 500. So, all the values I've just kept here. Just see what happens. This 1000 will cut this way. So, electricity you wrote there 10 raised to the power 4. Instead, it should be 10 raised to the power 3. Isn't it? So, what this value would be? I'm writing here. This would be 1000 kilocalorie per mole. Right? Sahin, Sultana, good noon. Very good afternoon. 1000 kilocalorie per mole. Right, electricity. So, the name that I am able to look at, that is I am using because I don't know your actual name, okay. So, electricity, you are absolutely right. Which option is correct now? That happens sometimes, but in the examination it should not be there, okay. So, 1000 kilocalorie per mole, it's there in the second option, the right answer for the question. Everyone, are you all got this question? If such type of question you find, you can answer this way, right. Now, let's talk about something more with respect to this activation energy concept, right. So, I hope you know that suppose a graph is given and here the reaction coordinate and here the potential energy that I have taken, right. And yesterday FTS was good only, chemistry portion was quite tricky, especially practical one was tricky, okay Bikram. So, nice to know that you find subject, the paper good, and it's also good that you find some of the paper tricky because if something is tricky, then you would be able to find out the portion in which you need to work more, because this is the moment when the time is to work hard, time is to revise, and all the concepts should be clear to you, right Bikram? So, keep practicing, it will be very easy soon, okay. Just check the question which were there from the practical chemistry, though this practical chemistry segment is new for you, I know. So, some of the things you need to remember, so try to learn them, okay. So, reaction coordinate, suppose you have the reactant H2 and I2, they are combining to form product 2HI, suppose, okay. Now, the energy of the reactant at this potential energy curve, it is here. The energy of the reactant I am taking, right, and say, ma'am, पूरी chemistry एक दिन में revise कैसे करो? एक दिन में नहीं करना है. It should not be done in a single day. Just divide the segment in a way that on a daily basis you are revising all the subjects. Try to do that, right? Or you can make chemistry and say botany simultaneously, zoology and physics you can take. One day revise that, next day revise that. And definitely if final test series you are talking, then on a daily basis you will find test, and while solving that, just find out the segment in which you are facing difficulty. So, find out the time for the revision part, not revise entirely, because FTS also, if you just look at the paper, you find that part syllabus test initially, na? So, keep practicing that way, Okay, Mohit? So, here say the product is formed and its energy is here somewhere, right? Now just let me know if reactant has a less energy and the product has higher energy, what type of reaction it is? Endothermic or exothermic? Just let me know. Suppose a graph is given. Let me just draw this graph. Say this is the graph where reactant has less energy and product has more energy. What type of reaction it is? Endothermic or exothermic? Let me know. Just write there in the chat section, in the comment box. Reactant has lower energy, right, Mohit? And product has higher energy. It means that product formed and absorbed certain amount of energy, right? And definitely, Lakshmi, endothermic reaction it would be, right? So we can simply look at that this is representing delta H for the reaction, right, Karthik? So delta H for the reaction, if you just look at, we know from the chapter thermodynamics that this is the sum of the enthalpy of products minus sum of the enthalpies of reactant. This we take, right? And in case of endothermic reaction, as the enthalpy of the product is higher and the enthalpy of reactant is lower, then this value would be positive. And positive value of the enthalpy of reaction represents endothermic reaction, right? So this been observed from the graph as well. Now, this is the portion of the graph which is representing, this much of the energy is representing the reaction enthalpy. Now, what about this energy, which is, let me erase this portion so that graph would be a bit clear. I'm talking about this energy. What this energy is? Good afternoon, Kumaran. Very good afternoon. So what we are discussing here, the question based on the chemical kinetics and more specifically the Arrhenius equation, energy of a reaction, and more specifically we are talking about activation energy. Actually, this is the graph where reactant is here, product is here. Here the activated complex or the intermediate is formed. This would have the higher energy, and for initiation of a reaction, this much of the amount of energy needs to be provided as EA, activation energy. The reactant has certain energy, but that energy is not sufficient to carry out the reaction. So we have to provide certain energy from the outside, right? And that is activation energy. And as this activated complex or the intermediate is formed, then it will lose energy to form the product. Product has lower energy. That's why this is the actual reaction pathway that you can observe, right? Now my question is, what happens if we are using the catalyst in this reaction? What will happen? What catalyst will do? Whether it will change delta G or it will change the equilibrium constant, what it will do? Or it changes activation energy. What it will do? If I am using catalyst, then which of these terms will be affected? Even the delta H. What would be affected? Reduces EA, right? Activation energy decreases, right? Mohit, Lakshmi, electricity. Delta G remains same, very true. Gibbs energy will not be changed. This delta G will not be changed. Equilibrium constant will not be affected because catalyst catalyzes reaction, both the sides of reaction. It means forward as well as backward reaction at the same rate, right? So that will not be affected. This EA would be, activation energy would be lowered or decreases. So catalytic reaction if you are using, then definitely, let me take here the other color. Hope it is represented here this way. So this is for the catalytic reaction, right? So this is something about the briefing about the catalytic reaction. And one more thing, catalyst always catalyzes the spontaneous reaction, not the non-spontaneous one. Okay, so the lines which I have used are generally asked in the question papers and even in the previous year exam also. EA will become less. Yes, Mohit. Yes. So now the question comes. Suppose the two different temperatures are given and the value of the K is dependent on that. That would be altered. Now in that case, if it is asked to find out EA, then which formula would be used? Remember, using Arrhenius equation, we have just derived one expression that log K2 by K1. This is also important. Based on this also you will find question. Can a reaction have zero activation energy? Is it possible? This is the formula that we used. Arrhenius equation, and you should know that based on this formula, number of times you find questions come in the examination, right? So for this question, electricity, we have to move with the NCERT, and as per that, zero activation energy would not be aligned. Okay? Now, log K2 by K1, EA by 2.303 R, T2 minus T1 divided by T1, T2. So learn this formula. Based on this formula also you find the question, though the calculation is a bit tricky, more calculation you have to do in this case, but yes, question you will find in the previous year examination as well, or aane wale NEET exam mein bhi ho sakta hai, right? Shall I move forward now with the next question, right? Question number 51 we have. So the question is based on what? The mole concept, stoichiometry. Volume of nitrogen required at STP to produce 10 moles of ammonia through the Haber's process. Remember the Haber process? The manufacture of ammonia, right? And in the manufacture of ammonia, what you do? Nitrogen reacts with hydrogen. The catalyst used is iron, and for this we use the promoter as well. What's the promoter in this case? Let me know. What's the promoter in this case? Haber's process, what's the promoter? Yes, I'm waiting for next 20-30 seconds, okay? So this is the reaction, N2 plus 3H2, BB. What BB? Karthik? Molybdenum, I think you were writing. Okay, you are writing the answer. Okay, Karthik, Mohit, you all are writing. My question was, what is the promoter for Haber's process for catalyst iron? That is molybdenum, right? MO. Yes, these are the conditions. Low temperature, high pressure. Very good, Mohit. And simultaneously the promoter, with this iron catalyst, we use molybdenum. Okay? Right. Let's solve this question. So here, nitrogen, 1 mole reacts with 3 mole of hydrogen, and here's the production of 2 mole of ammonia as per the reaction stoichiometry. They are not talking about some limiting reagent. They just look at the reaction and wrote here that how much amount of reactant is needed and how much product is formed. Now the as per question, if you just look at, you want to produce 10 mole of ammonia. So here 2 mole of ammonia is there, and for the same, the nitrogen which is needed is 1 mole, right? Now instead of that, if you want to prepare 10 mole of ammonia, then apply the unitary method. For 2 mole, 1 mole of nitrogen is needed. Then for 10 mole, definitely half of the amount of ammonia is needed in terms of nitrogen, right? So for 2 mole, 1 mole. For 10 mole, 5 mole of nitrogen is needed. But they're not asking to find out the moles. They are asking you to find out the volume at STP. And everybody is aware that 1 mole of a gas at STP has a volume 22.4 liter, right? So 5 mole of ammonia, nitrogen you have, then volume of ammonia would be 22.4 into 5, right? Just multiply, 112 liter. Very good. Lakshmi, electricity, science, Sultana. Okay, Mohit, everybody is participating. This is very good. So 112 liter. Clear it is, everyone? So such type of question could be asked. Instead of volume, they can ask you to find out the number of atoms which are present in the given amount of nitrogen. So in that case, moles you have. Multiply Na to get the molecules. Multiply 2 to get the number of atoms. Done? Sometimes they can also do, they can just tell you that how much nitrogen is required for the process, the one thing. And the second thing, they can ask that the same amount of nitrogen is being used for the production of nitric oxide. Suppose, I am just extending the question, that same amount of nitrogen is utilized for the production of nitric oxide. Then what would be the volume of nitric oxide produced? So if the volume of nitrogen obtained, you know, the nitric oxide would be double in the volume in that case. N2 plus O2 to give you 2NO, right? So that type of question could be the extension of this way, okay, right? So जब भी आप question paper solve कर रहे हैं, you can just think about other questions which could be asked based on this present question, right? चलिए आगे बढ़ते हैं. So in this continuation, I have taken another question. Because I have taken some of the question from the previous year or the regular question from study package or some NCERT. Very good afternoon, Dashrath join. Okay, so what we are discussing here, the questions from the paper MT8, that is from the AIATS Plus Phase 2 program, and some of the question we have discussed, and this is another question here. Volume of oxygen required at STP. So this is the question once again, based on the mole concept and simultaneously the reaction stoichiometry. So volume of oxygen required at STP to react completely with 180 gram of ethane, right? Solve this question. I hope you know the combustion of a hydrocarbon in complete combustion it is, right? So complete reaction needs the sufficient amount of oxygen. So we have to balance it. Calculating the mass percentage of element is difficult. Okay, I'll check. Give me a moment. Let's solve this question. Then I'll come to that, Lakshmi. Okay. So C2H6, when burnt, it forms CO2 and H2O, right? And enormous amount of heat would be released, right? So this is combustion. Let's balance this. 3H2O. Now oxygen is 4 plus 3, 7. So I can mark here 7 by 2. This is the balanced chemical equation, right? Lakshmi, Bikram, Sahin, electricity, Dashrath, everyone, just have a look, right? This is the equation of the combustion of ethane. Now, the question is volume of oxygen required. You know, you have to find out the volume of this oxygen which is needed for complete combustion of 180 gram of ethane. So by just looking at this, I can simply say that if you want to burn 1 mole of ethane, then how much oxygen is needed? 7 by 2 mole of oxygen. Am I right? Now, how much amount of ethane you have? 180 gram. You have to change it into mole. So that would be better for the calculation. So 180 upon the molar mass of ethane, given mass by molar mass. Molar mass of ethane is what? C2H6. 30 it is. So 3 6 are 18. 6 mole. So if you have 6 mole of ethane, then how many moles of oxygen are required? Unitary method simply. Yes, Mohit, and electricity, maybe you are right. I'll just check, then I'll tell you. So for the 6 mole, 1 mole 7 by 2. So it would be 7 by 2 into 6. 7 3s are 21. 21 mole, right? And how much volume at STP it would be? The similar way you can do as just like the previous question, molar mass of ethane is 30. Yes, Bikram. So 21 into 22.4. How much it would be? Yes, you all are right. 470.4 liter. Right answer is option 1. Okay? Done? Clear? Yes, Karthik, Bikram, Mohit, electricity, everyone. Done? Now, Lakshmi just asked that calculating mass percentage is difficult. So, it's not difficult. Mass percentage, suppose in a particular compound you want to find out. So, the simple formula that we use for the weight by weight percent or the mass percentage, what it is? The percentage of mass of element if you are calculating. So, first you take the mass of element or the species which is given to you divided by the total mass into 100. This is the simple formula that you apply. right? Even in a solution also, suppose a solution you have and certain mass of the solution you have, and certain mass of solute is also given. So mass of solute divided by the mass of solution, multiply 100 Lakshmi, right? And if you are aligning with the empirical formula type of question, there you are facing difficulty. So suppose a compound you have carbon, hydrogen and oxygen is present there, and the specific mass, say X, Y and Z is given. Then find out the number of moles, right? So how to find out? Because this mass percentage will become, you just assume that the compound has the mass 100. So whatever the percentage you have, that would be the mass. And how to find out the moles? So X by 12, Y by 1, Z by 16. This is how you find out the moles. Then the simplest ratio can be identified by just dividing the lowest number. Take the lowest number and divide this everything, right? So lowest number is Z by 16. Take that. No, not every time, because we don't know about the Z value, right? So you have to find out it. Then you can find out the simplest ratio, right? So any specific question, if Lakshmi you have, you can post there. I'll check. Okay. Now, let's take the question number 54. Maximum number of spectral lines in visible region when an electron jumps from 5th orbit to the ground state in hydrogen spectrum. The simplest type of spectrum for the hydrogen, the single electron system, uni-electron system we have. And I hope you know that N is 0, that we treat as the ground state, right? Okay. Now, N is 1, and distance is but decreases, N is 2, then 3, 4, 5. This way. And as you are moving upwards, the distance between the lines decreases. This happens. Now the question is maximum number of spectral lines in the visible region when an electron jumps from 5th orbit. So N is 5. It's jumping from here and coming down to the ground state in hydrogen atom. Then if it is coming directly to the ground state, then what is the possibility of the number of line? How many lines could be there? So you start from here, 1. Then from here, 2, 3, 4, and then 5. You can say this, but it is incorrect, because in the question they are saying that in the visible region you need to check. Visible region, VIBGYOR, that you are able to see from the from your eyes, right? Option 3. Okay. So visible region means N is 2, right? From 5th level, if from to this N is equals to 2 level, if electron is jumping, so 1, 2, from 5th to 2, from 4th to 2, from 3rd to 2. These are the spectral lines, those you are going to get, right? So whenever is this type of questions being asked, you have to just read each and every line, because they are focusing on visible region. That's why N by 2 I am taking. Suppose they ask you that in UV region, then you have to take the Lyman series, N is equals to 1, right? So I hope you are able to recall that for Lyman series, the N1 value is 1. For Balmer, that's for the visible one. This Lyman is for the UV, right? For Balmer, the N1 value is 2. Paschen, N is 3, then bracket, 4, and fun, 5, right? Yes, you have to check up to Balmer, because visible reasons being mentioned. And if they are saying that UV reason, then up to Lyman you have to look at. If they say Paschen, that is the IR, so IR includes 3, 4, 5, right? Okay. So if such type of question you find, you can solve this way, and the right answer undoubtedly option 3, where the 3 lines being observed. Done? Clear it is? This type of question you can also find. Okay. So next is the turn for another question, because in the time limits, the prescribed time, we have to solve the questions as well, and try to we should not leave any stone unturned while solving these questions. So we'll try to take each and every concept, okay, with respect to these questions. So question number 57 we have. Half-life period of a first order reaction is 30 minutes. the rate constant of the reaction is. This is first order reaction, and they're talking about the half-life period of the first order reaction. Right? So in this case, what's the relation? Half-life T half for the first order reaction, that is independent of the initial concentration. Right? So T half would be, the simple formula is 0.693 by K. Right? And half-life period of a first order reaction is given. It means this T half value you have 30 minutes. So what would be the value of the K? So K is equals to 0.693. I'm rewriting it. The K value is 30 minutes. Right? To solve this, how much it would be? Because the rate constant is given in per minute. Which option is correct now? 0.693 by 30, right? So 3 2s are 6, 3 3s are 9, 3 1s are 3, right? So 0.0231 or 2.31 into 10 raised to the power minus 2 per minute. Right? Yes, Karthik, Sign, Mohit, everyone, electricity, everyone correct. Okay, Lakshmi as well. So these are, this is the value, and the right answer for with respect to this becomes option 3. Clear? Done? So this was another question from the chapter Chemical Kinetics, and the turn comes for next question. This is from the chapter Chemical Bonding, right? The chemical bonding and the molecular structure, and the question is the matrix match type of question, the favorite type of question which has been there in the NEET examination. NTA follows this pattern a lot, okay? So the list 1 you have to match with the list 2. List 1 has certain species. In the list 2 you have to just check the number of lone pairs around the central atom. Now have a look on the given species one by one. SO2 if I'm talking. Right? The bent species, and there is 1 lone pair. 6 electrons in the unbonded state. Okay? Right? Steady empire उससे भी निकाल सकते हैं, उससे भी निकाल सकते हैं, formula से भी. Right? So it's up to you. The way which you find good, you can use. Okay? So SO2 की बात करते हैं. This SO2 has 1 lone pair. So on the central atom, not the, as per this, the number of lone pair around central atom. If total can be solved by SO2 only, can be solved by SO2 only. I'm not getting, bache. Okay. SO2 if you talk about, so on the central atom you need to look. Suppose they are saying the total number of the lone pair, then you need to count the lone pair on the oxygen atom as well, right? So here it's matching with the second one. Then CHCl3, chloroform. Chloroform central atom carbon bonded with the tetrahedral manner. 4 electrons are there on the central atom and bonded this way. There is no lone pair on carbon atom in case of CHCl3, right? So if it is so, it would be 0. The simple question it is. If you know the structure, if you know the way to draw the structure, and that will help you to solve such type of question. Very easy question. IF3, what's the shape of IF3? Right there. What's the shape of IF3? I'll be taking XeF2 first of all. XeF2. Write the shape of IF3 in the comment section. Xenon you have 2 electrons of it are being utilized in bonding with the fluorine. The remaining lone pair, total electrons 8 on the xenon, it means 4 lone pair were there. 1 get involved in the formation of bond with fluorine, right? Linear it is. 2 fluorine atoms are bonded this way, sigma bonds. And 3 lone pair. Done? Right, Mohit? Absolutely right. That I was asking. So, XeF2 has 3 lone pairs, right? And 3 lone pair, it means you can directly match it. XeF2 has 3 lone pair. What about IF3? T-shaped it is, right Lakshmi? T-shaped. So, centrally located I, do you know one more thing had happened here? Because of the lone pair repulsion, this get slightly bent because of the lone pair repulsion, VSEPR, right? So, this could also be the way, okay? Now, IF3 has 2 lone pair, yes. So, I have just matched it. Now, what would be the right answer this way? A2B1, A2B1, C3D4. Third option is the right answer. Clear? So, how to find out hybridization? For the finding out hybridization, just look at the steric factor. Steric factor is total number of sigma bond plus lone pair, right? Suppose someone asks you that what is the hybridization of this SO2? So, sigma bond 1, 2 and the lone pair 1 on the SO2, right? So, what's the hybridization in this case? Steric number is 3 and if it is so, sp2. Clear? Done? Now, sometimes the bond angle could also be asked. Like what is the bond angle in chloroform and the central carbon atom? So, tetrahedral it is, right? Even in case of SO2, it seems 120-degree bond angle, no, but it is 119.5. So, in the NCERT, whatever the bond angle values are given, just have a look on it. In case of BF3, the bond angle is 120 degree, ammonia 107, in case of water 104.5 degrees. So, that you need to remember because whatever is given there in NCERT, that's a very important thing. That's why it is called the Bible of chemistry, right? Okay, let's move forward. And from the same chapter, I have taken another question, right? 109 beta, not 8. 109 degrees, 28 minutes of arc. Sign, I think typo error it is. Okay, so this is the question again from the chemical bonding. And what it says that 2 statements are given. One is assertion, other is reason. Assertion statement you have to read to find out whether it is 104 degrees, 28 minutes of arc. Acha, 4th option. Okay, Mohit. Assertion says the resultant dipole moment of NF3 is greater than that of NH3. The first statement. Okay, and now I got it. What I was just looking at, I just thought that you are replying with respect to the value written by Sahin Sultana. Okay, now I got it. Okay, electricity and Mohit. So, assertion statement says dipole moment of NF3 is greater than NH3. So, in the one line we can say it is incorrect. Okay. Mainly from NCERT beta. Sometimes it can be based on the logical reasoning, but generally they ask from the NCERT. Right, Lakshmi? You cannot skip any line from the NCERT. Okay. Reason says fluorine being more electronegative than hydrogen leads to greater dipole moment of NF3 as compared to NH3. So, in this case, the reason statement is also that it is saying fluorine being more electronegative than hydrogen leads to greater dipole moment of NF3 as compared to NH3. So, once again it is saying that NF3 has the higher dipole moment. It's incorrect. See, if I am talking about NH3, this is the lone pair, right? Now, just look at the bond dipole of nitrogen and hydrogen. Nitrogen is more electronegative, so the alignment of the bond dipoles is upwards. What about the dipole with respect to the lone pair? That is also upright. Okay. So, I hope you know that in case of dipole moment, we sum up the bond dipoles to get the resultant one, right? So, these 3, the resultant of these 3 is also in the upward and this is also in the upward. These 2 are actually creating the more charge separation, more polarity there. Okay. So, this would have the value, certain value of mu, the dipole moment. Now, if I am comparing it with NF3, the lone pair we have The dipole due to the lone pair is upright. But what about the bond dipole? These would be towards fluorine, right? Because fluorine is more electronegative as compared to nitrogen. That's why the reason statement is incorrect. So all three bond dipoles are giving the resultant which is in opposite direction with respect to the dipole due to the lone pair, right? And they are somehow reducing each other, okay? And that leads to the higher dipole moment of ammonia as compared to NF3. Getting it? And if we identified the same, then we can say the first statement that resultant dipole moment of NF3 is greater, incorrect, and the reason which is mentioned here that fluorine is more electronegative as compared to hydrogen, undoubtedly. But the later statement that greater dipole moment of NF3 as compared to NF3, this is incorrect. Done? So both the statements are incorrect. Option 4 becomes the right answer. Clear it, everyone? So while solving AR, have to just read the statements very carefully, right? Because it can make you confused, though this is the simple one, but sometimes you would not be able to find out whether the slight change is causing the incorrect statement. Okay? Now, the next question, question number 73 from the paper, and this is again the simple question where certain elements are given in the column 1 and in the column 2, their natures being given. So, the simplest of the simple question, right? Column 1 says copper. Yes, copper is a transition element, we can match here. Instead of copper, if it was zinc, that is not considered as a transition element. Zinc, cadmium, mercury, I hope you know. Fluorine. Fluorine is a non-metal, definitely. Most electronegative element of the entire periodic table. Though the electron gain enthalpy, it has less as compared to chlorine. Okay. Germanium is a metalloid or the semi-metal. And cerium, 58 is the atomic number, lanthanoid. Simple. Matched. A2B1 C4D3. C4D3. Is it third one? Okay. So I'll be marking here. The third is the right answer. So very good, everyone. Simple question, but sometimes we make mistake in simpler questions as well. So turn comes for the another question from the same chapter, the periodic classification. The question is an atom you have with which of the following electronic configuration has the highest ionization enthalpy. What is ionization enthalpy? What is ionization enthalpy? That's the amount of energy, the enthalpy change you can simply say while you are removing the amount of energy required while you are removing an electron from the valence shell of an isolated gaseous atom, right? You are taking an atom in the isolated gaseous state and you are removing an electron from the valence shell. So the amount of energy that you need to provide. Now if the stable species you have, then more amount of energy you need to provide, like in the inert gases. They are inert, they have the complete octet, they don't have the nature to react, and that's why they're higher, they have the higher ionization enthalpies. So we have to look at the configurations given. See, 1s2, 2s2, 2p1. So from the second shell, p subshell you have, electron could be removed easily. 1s2, 2s2. So comparatively difficult to remove electron from here because of the higher effective nuclear charge. From the s subshell you are removing electron. 1s2, 2s2, 2p3, even higher ionization enthalpy is needed. 2p3, it means p subshell that is half filled, right? And the more exchanges are possible here. Half filled is considered as stable as fully filled one. If some fully filled is not there, then this would have the highest ionization enthalpy. And in the fourth option we have 2p4, right? So half filled configuration is violated, so it would not have the higher ionization enthalpy as compared to third one. So highest one is in the third, right? Very true. Karthik, Lakshmi, Vaishnavi, Electricity, Mohit, everyone, Sahin Sultana, all are correct. Option 3 is the right answer. And it's very simple. This is the configuration for nitrogen. Nitrogen has higher ionization enthalpy as compared to oxygen, right? Remember? Okay. Chaliye, aage badhte hain. Next is the question once again from the same chapter, and the question is the correct order of the negative electron gain enthalpy for the given group 16 elements. So what is can order of ionization enthalpy for this? Order of ionization enthalpy can also be asked, beta. That can also be asked. See, in this question, The highest is aligned for the third one, right? Highest is for the third one. Now the removal of electron is, if I am comparing the fourth one and the first one, then fourth one would have less ionization enthalpy as compared to fourth one, then turn for the fourth will come and then second one, this way. Okay. Now, yes, question number 63, and I got the answer from the Mohit as well, right? See, negative electron gain enthalpy. So, whenever an electron is being added to the valence shell of an atom in case of its isolated gaseous state, then the enthalpy change is considered as electron gain enthalpy, and generally it's been observed that the value of electron gain enthalpy is negative. Okay. In case of noble gases, you find that electron gain enthalpy value is positive, right? Okay. 3 is nitrogen. Yes, Sahin. Oxygen will have least because of its compact nature. Okay. Small size, and there the higher interelectronic repulsion, Mohit. Rather writing compact nature, high interelectronic repulsion you can say. Okay. So, in group 16, the order of electronegativity we say that as you are moving down the group, you find that electronegativity decreases, right? So, if I am asking you that what happens to the electronegativity, so oxygen is more electronegative as compared to sulfur. Right? But what happens? In the electron gain process, oxygen will attract electron undoubtedly more as compared to sulfur. But what will happen? That electron should be gained. And for the coming electron, that electron will feel more and more interelectronic repulsion. And that leads to the less negative value for electron gain. Right? Hello, Yuvraj. I am able to read your name, though it was, written in some other script. Okay. Group 16, the elements are this way: oxygen, sulfur, selenium, tellurium and polonium. Electronegativity decreases moving down the group, but oxygen, because of its small size or the compact nature as written by Mohit, it has high interelectronic repulsion, and that leads to the less negative electron gain enthalpy. So, the order would becomes highest for the sulfur, then selenium. This is a very different order. If you just look at group 17, you find that after chlorine, fluorine is there. But oxygen will find the position at the end, this way, right? So, the correct order: sulfur, selenium, tellurium, though they left polonium, so I will erase polonium from here. Instead of that, I will be writing oxygen. So, this order is here in the option 2. Clear? Sulfur, selenium, tellurium and then oxygen. Done? Mohit said 1. So sorry. The order, we have to just look at the mark as well. The highest for sulfur, then selenium, then tellurium, then oxygen. The reverse is it. So, this is very important to look at the pattern, the symbols, the signs in the question, right? Don't do this mistake. Okay? Done? Shall I move forward? Next is the question number 74, and this is the question from concentration terms. And the concentration term about which they talked here, molarity, right? Now, question is 0.98% weight by weight percent of H2SO4 solution. So, Lakshmi, maybe you find difficulty in the mass percentage, maybe that problem gets resolved here in this question. This solution has a density which is given, and what's been asked that to calculate the molarity. Okay. So, this is 0.98%. So, weight by weight. What do you observe from this? We observe that if the 100 gram of the H2SO4 solution you are taking entirely, then pure H2SO4 in it is 0.98 gram. .98 gram H2SO4 is present in it. Can I say this way? 0.15? Maybe beta, I have to check. So, 100 gram has 0.98 gram H2SO4, right? Now density of the solution is given. Sometimes this make you confused that which mass to be taken, this one or this one. So as the density for the solution is given, so we have to take this 100 gram as the mass of solution. Density of the solution is mass by volume. For the calculation of molarity, you want volume. So volume is equals to mass by density. Mass is 100 gram, that we assumed because percentage is given. And the density is 1.5 gram per ml. So it would be 1000 by 15. Can I say this is 200 by 3 ml? This is the volume. Done? Right? Now you have to find out the molarity of the solution. So molarity of the solution is moles of solute. And what is solute here? H2SO4, and its mass is 0.98 gram divided by the volume of the solution, and that should be in liter, right? So solute has the mass 0.98 gram. So moles of this, H2SO4 has the molar mass 98 gram per mole. So divided by 98. Further, volume of the solution you have just found, see, 200 by 3. So I am placing here 200 by 3, right? But it should be there in liters, so I have just divided it by 1000. So this 1000 will go upwards. Even this 3 will also go here. So this will cut this way, and 0.01, 2 zeros will cut this way. So 3 by 20, and that would be 3 by 2, 1.5, so 0.15. This would be the molarity. And everybody who have already calculated, whether Mohit, Lakshmi, Electricity, Science, Sultana, everyone, you all are correct. This is the right answer. So this is the question from the concentration term. And now one more question, which is the question number 78 from the paper, the correct order of energy of orbitals for a multi-electron species. How to find out the energy of the orbital, which principle we use? Just recall, in the second chapter, we studied at the very end, while writing the electronic configuration, you studied Hund's rule, Pauli's exclusion principle, Aufbau principle, right? And if you are calculating the energy of the orbital, you have to use Aufbau principle, right everyone? And what Aufbau principle says, there are the two things. One, n plus L value you have to look at, and then n value you need to focus on. These two values. What is n? The principal quantum number, right beta, right Bikram, n plus L rule. Yes, and if n plus L value is same, then n value you need to look at. So this is given by Aufbau principle. The orbitals which I am looking at here, 5s, then 5p, then 4d, then 4f, right? And for s, p, d, f, I hope everybody is aware, it is 0, the L value. L value is 0, for p it is 1, for d it is 2, for f it is 3. Right everyone? Just find out n plus L value for all of these. For 5s, the n plus L value is 5 plus 0, 5. For 5p, 5 plus 1, 6. Definitely 5s would have less energy as compared to 5p. Then 4d, 4 plus 2, it is 6 again. And 4f is 4 plus 3, 7. So highest energy for 4f and the least energy for 5s. Now the question is between these two, 5p and 4d. Then if n plus L value is same, then you have to look at n value. The less n value, less would be the energy. So a less n value is for 4d. So 4d will come, and then turn comes for 5p. 5s, 4d, 5p and 4f. The second option, right everyone, very good, very good. The second option is the right answer. Clear? So just recall all these rules, those you have studied. Now this is the turn to revise. So this way we have solved few of the question, discussed few of the concepts, and tried to complete these concepts in a way that if the question in the NEET examination you find based on such concept, you would be able to do that correctly. Because every time with respect to each question, we want plus 4 marks, not less than that. Right, everyone? So keep preparing, keep practicing. So here onward, there is the lunchtime, and then another session would also be there. Another separate link for the session is there. Stay tuned, and teachers would be there to help you out. My best wishes with all of you. Thank you so much.